Hello, welcome back to our second lecture series on deterministic finite automata. In today's class, let us take up one problem and see how exactly a deterministic finite automata can be designed to any given problem. So to which I am going to take a standard problem of creating a deterministic finite automata for a language which always ends with ABB. Okay, so I'll say the problem number as 1, and here construct a deterministic finite automata for the language which which always ends with ABB. This is what we are going to construct. Now, what he is saying, any string, it has to end with what? ABB. Now, the same thing with, if I am going to write it as a language, I will tell you how it looks like. It looks like this. L is equal to A plus B whole star ABB. Okay. A plus B whole star is, it can start with either A or B or anything, but it is always ending with what? ABB. This is what our main concern is. So I am not going to confuse you a lot. So what I'll do, I'll just remove this. We'll see that later. Now what they are saying basically is it should always end with what? ABB. It should always end with ABB. Now, when such problems are given, first you need to think what are the strings that are accepted and what are the strings that are rejected. Now see, accepted strings for this problem is ABB itself, right? It is ending with ABB, no? That's why. Now it can also start with A, no? ABB. See, it is ending with ABB again. Next, it can be B, ABB, also accepted, AB, ABB, also accepted, and so on. These are the strings that are ending with ABB. Now, the rejected strings. What are the rejected strings? Suppose if I have AB, it should be rejected, BA, it should be rejected, AB, it should be rejected, BAA should be rejected, BBA should be rejected. So these are the strings that need to be rejected according to the given problem. So now what we do, let us not worry about the rejected strings, and I'll keep only the strings to be accepted on the board. Now, in this accepted strings, you just have to think what is the minimum string that I need that should be accepted. The minimum string that need to be accepted is what? ABB, no? Here we have ABB. This is what should be accepted. This is the minimum string. So using this minimum string, we are going to construct a skeleton DFA. What do you mean by skeleton DFA? See, in the last class, we have discussed there will be so many transitions from one state to other state. But now skeleton DFA consists of accepting the basic string. The basic string that is accepting is what? ABB, right? So for that, let us construct a DFA. I will start from the state Q0. From Q0, what is the first symbol we have? A. So A is the first symbol, and then I have Q1. From Q1, I am going for the second symbol, which is called B. Then we have Q2. From Q2, we need to go to the state which is called Q3. Now, what is the other symbol we have? B. So, this is what is nothing but the skeleton DFA. The minimum string to be accepted was ABB. Now, I have written a skeleton DFA for a minimum string that from first state to second state I am taking A. From this second state to the third state I am taking B. And from third state to the last final state I am taking B. So, we are ending with ABB. So, this is the skeleton DFA. After writing the skeleton DFA, what we are supposed to do is we have to add more transitions in such a way that all the other strings that you have in the example is accepted. Let us see how I am going to add it. How many states we have? 4 states, Q0, Q1, Q2, Q3. So let us write it. So set of states is having Q0, Q1, Q2 and Q3 are the set of states I have. Now what are the alphabets I have? So alphabets as per the given problem is A comma B are the alphabets we have, right? Now see on Q0, what is the transition that I have taken? A. Does it have any transition on B? As of now, it doesn't have any transition. Now, before solving this problem, there are two important things I need to tell you with respect to deterministic finite automata. So let me tell it. I'll take a new page for that. This is very important and this is the basic concept. Try to understand this. The definition says deterministic finite automata. What do you mean by deterministic? Deterministic says, see, suppose I am in state Q0. From Q0, if I am going to Q1, okay. Now, what is the symbol I am taking? A. Now, if I ask you a question, from state Q0, if you take A, where do you go? You are going to say Q1. Suppose if I had a transition here over A, now see, this is a self loop. On Q0, by taking A, you are going to Q0 only, no? Now if I ask you the same question, on Q0, if you take A, where you are going? Now you are in confusion, whether I want to tell Q0 or whether I should tell Q1, isn't it? So for this, for this ambiguity, you are going to call it as NFA. So what I am trying to tell you is, in any state, for a symbol, there will be only one transition. There cannot be multiple transitions. So now this is NFA. Suppose if I remove this, it is DFA. Now I hope you understood this concept. So in deterministic finite automata, from any state, if you want to go to another state, there should be only one particular symbol for that particular transition. There should not be any ambiguity. You should not think the transition should go to multiple states. It should go to only single state. That is one point. Now the second point that I would like to add here is, now let us say you are in some state Q0. When I am in state Q0, there are 3 types of transitions I can make, not only in Q0, in any state. So let me remove this. Suppose let us say I am in some state, general state Q. I can go for 3 type of transitions. What are the 3 transitions? I can go further, I can go backwards, and I can go to a self loop. So these are the 3 type of transitions we have. What are the transitions? I can go further, I can go towards the next state, I can go backwards, or I can go to a self loop. Now keeping this in mind, let us try to solve this problem. Okay? Now, see, you are in Q0, right? Q0 already is having a transition on A, it is going to Q1. Now, concentrate on this particular string. It is starting with what? B. Now, when it is starting with B, there are multiple options. It can start with only B, A, B, B. It can start with 2 B's, A, B, B. It can start with 3 B's, A, B, B, and so on. Correct? So for that reason, what we are going to do, we are going to give a self loop for B. Now what this self loop indicates? Self loop indicates that B can be considered for 0 or more number of times. I'll repeat again. Self loop indicates 0 or more number of times. That means what? If you consider it as 0 times, you are getting ABB. If you consider it as 1 time, you will get BABB. If you consider it as 2 times, you are going to get BBABB and so on. Clear? Now, Q naught is having a transition on both A, it is having a transition on B. We are done with the transitions on Q naught. You cannot give any more transitions. Now let us go for Q1. Now, when I am in Q1, it is already having a transition on B, isn't it? Can it take a transition on A here? No. Why? Because it should always end with what? ABB only, no? So I am not going to add I should not add A here. It is not correct. But now, as I told you, if you have a state, you can go further. You can go to a loop or you can go backwards. No. Further is cancelled. Now I should think of a loop. So, can I give a loop here for a transition A? You think about it. See, what the question says, the string should always end with ABB, no? Now see, if I give a self loop here, is it not ending with ABB? It can be one time, ABB, ending with ABB. If you take two times, again ending with ABB. If you take it three times, again it will be ending with ABB. So you will not think of going back here. You will think of going further, right? So this is a correct transition which we have added. Now, can you give any more transitions to Q1? No. Why? Because there are only two input symbols, that is A and B. It is having a transition on A as well as it is having a transition on B. I cannot give and add any more transitions here. Now let us go back to Q2. In Q2, let us take a string. I am going to consider a string of this kind. Now let us say I have started from here. I will take the first B. What is the first symbol that I am taking? B. With one self loop. Then I am taking A. Then I am taking one more A here, assume. Okay. After that, what I have? B I have taken. Now I am in which state? I am in Q2, no? Now assume if you have got a transition A here. Suppose if I get a transition A here, I should give it back like this to the previous state. Why? Because it should always end with ABB. See, after reading this much till this B, if he is trying to read A, you are sending him back. Take this A and again end with BB. Is it not ending with ABB? That is why you are giving a backward transition for A. Next, we are at the state Q3. So in Q3, if it is ending with, if it is taking A, where it should go? It should always end with ABB, no? It should go here. See, I am in state Q3. If it is taking A, it should go here. Why? Because it has to end with ABB. If it is taking B, where it should go? You tell me. If it is taking B, can I give it here? No, because it ends with BB. If I give one more B here, this is a self loop which says 0 or more times. If it is 0 time, A will not be considered. It ends with triple B. That's why if it is taking B, it should go back here. So at last, if you are taking B, send him back to the first state so that he will always end with ABB. This is how you are going to write a transition table which always ends with ABB. Now, this is not enough. We need to construct its equivalent transition table. So quickly, let us try to construct its transition table. Now, in the last class, I told you how to write a transition table. Let us try to write it. How many states we have? 4. So let us write Q0, Q1, Q2, Q3. 4 states. What is the final state? Q3. What is the start state? The start state is Q0. So this is the start state. So now, what are the input symbols we have? A. What is the input symbol? Second one we have. It is B. Now, transition symbol. Q0 on A, where it is going? Q0 on A is going to Q1. Okay, Q1 on B. Q1 on B is going to Q naught. I mean Q0 on B is going to Q naught. Next Q1 on A. Q1 on B. Q2 on A. Q2 on A is going to Q1. Q2 on B is going to Q3. Next Q3 on A is going to where? Q1. Q3 on B is going to where? Q naught. So this is how you are going to write it. Sorry for that. Transition table. After all this, you should also mention whether the given string is accepted or rejected. So I'll tell you quickly how to tell whether the given transition is accepted or rejected. Let us take an example. Suppose I'll take B, A, B, B. It should be accepted or rejected. Obviously, it should get accepted because it is ending with A, B, B. So for this, what we are going to do is, I'll write a transition from Q naught and the string is this. Now see, Q naught on B, where it is going? Q naught on B is going to Q naught. So you will remain in state Q naught with the remaining symbols ABB. Now next, Q naught on A, where you are going? Q1. So the state will change to Q1, remaining string will be BB. Now Q1 on B, where you are going? Q1 on B, you are going to Q2 with the remaining symbol B. Q2 on B, where you are going? Q3. Did you reach the final state? Yes. Hence it is accepted. That is how you are going to tell whether the string is accepted or rejected. Now suppose in the same example, if I add A here, it should get accepted or rejected? It should get rejected. Why? It is not ending with ABB, it is ending with BBA. Now see, these steps remain same, but here you will have A here. Now what happens? In this step, you will get Q3, comma A. Now, Q3 on A, which state you will go? Q1. Is it a final state? No. Hence it is rejected. That is how you are going to show acceptance and rejectance in the finite automata. So, in any given problem of deterministic finite automata, I'll just tell you the quick steps how to solve it. First one, you understand the problem properly, write the accepted string, write the rejected string, and in the accepted string for the first particular string that you have, try to construct a skeleton DFA. Then for each state, you need to see the possibilities. That is, whether I have to go forward with a symbol, or I should go backward with a symbol, or I should go for a self loop. You need to decide what is the correct option to make. So this is how you are going to solve the particular deterministic finite automata problem. After writing the transition table, after writing the transition diagram, you need to write a table. After writing the table, you need to show acceptance and rejectance. That is how you are going to complete the given problem. So this is the first problem that we have solved in deterministic finite automata. In the upcoming classes, let us solve more and more such problems. Thank you for watching and please subscribe the channel.